All right. Shall we start, Chris? You ready? Super. Hi, everyone. I'm Keyur Patel, and we have here Natalie with us, who's our CyberOps secretary, and I have Chris Morrow, who's my co-chair, joining us remotely. Chris, you want to say a quick hi?
Hello.
Super. Um, this is a note well. Most of you know what this means. This is about IETF policies and more importantly, talking about code of conduct as well as patents amongst many IETF policies that's been discussed. For those who are new at CyberOps working group, you want to pay an extra attention to this. And on the agenda, we have 5 presentations. We have Tim talking about challenges and lessons learned in deploying a couple of RFCs, 8492, 8181, and 8183. Then we have both Igor and Sriram talking about an update on SAV using BGP for ASPA and ROA. Then we have Signtel that Tom's going to talk about. Again, update on ASPA verification from Sriram. And finally, Job is going to talk about update on RFC 6482 base. Any questions on agenda before we start? Super. Tim, you're on. I don't know if clicker works. You just tell me.
Yeah. Hi, everyone. It's set 20 minutes on the agenda, but I'll try to be shorter. Maybe we'll have some discussion though. Let's see. I wanted to talk today about the experience that I've had firsthand in the last couple of years implementing these RFCs. Maybe next slide. Before we start, I want to say a big thank you for creating these RFCs. I think by and large they work actually very well. We see a lot of deployment, different implementations, different instances. So I'm not here to say we have an immediate problem that, there's, well, I hope it comes across. Although all of this stuff essentially works, I think there are also things that we can improve. Next slide, please. If the numbers don't mean much to you, and I can imagine they don't, there's 3 RFCs I named. So 8183 is about the exchange of identity certificates essentially between different parties in the RPKI. So a child CA needs to talk to its parents to get certificate signed. ACA needs to talk to its publication server to get its signed content published. There's an initial setup for that. That's 8183. And then there's the provisioning protocol 6492 and the publication protocol 8181. Next slide, please. So, as I just mentioned, is there anything missing? Well, yeah, I think that based on experience, some things might be missing, other things can just be improved. And the urgency of these things, well, I guess that's to a degree a matter of opinion, but also it varies a bit from topic to topic. But I'd like to go over the fairly long list of things that I wanted to say. Next slide. So, starting with the general protocol. What I have found is that the definition of the CMS messages and the identity certificates used in the communication is fairly loosely specified, and this can lead to some interop issues because you don't want to just accept everything that's possible in CMS or certificates. So you kind of narrow it down, and it makes sense to do it in a similar way as what we're doing for the resource certificates. But then, you find that some implementations use additional things, and then you need to go back into your code and make fixes at an ad hoc basis. So this can be a bit annoying. Replay protection can be improved, I think, because currently there's text that says that the signing time of the CMS cannot regress essentially, which is okay, but might not be enough. For example, if I ask my parent for my resource entitlements and I get a message from before, but it's not regressed, it's just the same message, then technically speaking, I should accept that. So a man in the middle could essentially keep me from learning changes. Identity key role is a thing at scale. So one implementation that I should say one deployment that I work with have well over 1,000 delegated child CAs, so they're on their own systems. And they need to do this exchange initially, but what if you want to change your identity key, for example, because you want to start using an HSM and you weren't before? Do you go out to all of these CAs and ask them to do another exchange? It's difficult from a scaling perspective. Signing algorithm for the messages, it's all RSA 2048 and SHA-256, and I don't think we have a plan for changing that. And we may want to think about it. Next. Then more on the control of the messages. Error messages, there are quite a few error messages and some of them are really useful, but I think there's also room for improvement there. Rate limiting is something we may want to think about, and then, I don't know, there may be other things that other people have run into that I'm not aware of. Next slide, please. Now more specifically on the publication protocol. So there has been, from time to time, people suggest that maybe publication server should be more proactive in what it accepts from CAs. Relying parties cannot trust the repository inherently. They need to do their own validation. But still, if a server would, apply some hygiene, there is some attraction in that. So things you could think about is like, should a server protect against certain object types, syntax? Should it be insist on the consistency? There's actually an error message for that already. So, but then if we go down that road, we also need to consider the risk of server errors. So what if a publication server has a bug, or is just not up to speed with the latest developments, and it starts rejecting things? Then how does the CA deal with this? So it's not as trivial as we might think. Quota is another thing. It's hard to say what quota should be. Probably it's something that is on a per publisher basis. But then again, yeah, we'd like to protect against CAs just publishing 1 million objects and causing relying party software all over the world to download all that stuff. And I think it would be good if we had something in the protocol for that. Server notifications or resync, these question marks, are about a specific outage that I witnessed, where essentially there was a configuration mistake applied to the publication server and it had to be restored to a previous version from backup. And what you get then is that CAs are out of sync with the publication server, but they don't know. They think, I published a new manifest URL, everything is good, I'll come back tomorrow. But the rest of the world sees their old manifest URL and they expire. So should we proactively poll the publication server, or should the publication server maybe send a message out and say, hey, I'm back up and this is the state? Or I don't know, maybe we need to think about that. Next slide. Similarly, in the provisioning protocol, when are resources safe to use? That's also a concern. Specifically, when will my certificate with new resources be published? Now, this is written in a CPS, but I can't really parse the CPS. I don't know where it is, and I don't know how to parse PDFs. So, but yeah, if you give a new resource to me, if my parent gives me a new resource and I delegate that resource to a child CA, before relying parties have seen the certificate issued to me, then now suddenly my child is invalid. So similarly, removal of resources, it might help if there would be some advance warning. Similarly to before, how frequently do we poll the parent for what the entitlements are? Have they changed, or should maybe the parent have a notification mechanism like we have, for example, in RCR, that they can say, you may want to talk to me. Algorithm agility, there's a document describing what we would have to do if we wanted to use other algorithms in the RPKI. And essentially, it is based on having separate trees for a while and a new document that defines flag dates for going from one to the other. I don't really want to go into the detail of that right now, but the point is more, as a child CA, I have no way of knowing that this is going on, what I'm supposed to do. So probably if we're going to do this, we would need something that, okay, a little bit of detail. The response that the parent gives me is essentially, these are your resource classes and your entitlements, your resources in each resource class. So most likely you'll need something that says, here you have resource class A and you can do RSA there. You have resource class B and that's where you can do elliptic curve or, you know, whatever it might be. But something like that we will probably need at some point, because currently we have a document that describes how we could do algorithm roles. But I don't think that in practice we can make this work, at least not for the world where you have delegated CAs. And there may be other things, of course, which other people have seen. Next slide, please. Now, what would be requirements if we think about changing all of this? I think it's really important that we basically don't leave anybody behind, at least definitely not from the start. So we would need some kind of graceful negotiation of protocol of capabilities or something. What might help is that we stay to the current protocol as closely as possible because it's less work, but of course provided that we can do it in a safe way. And then other questions come to mind, like, okay, if we look at all of this and other potential things that people might think of, will we go for a new version that tries to fix all of the issues, or which might be hard, or you know, is there a way to do things incrementally and say, okay, these things are really important, can we address those first? What I propose, this is the last slide actually, and to start with the bottom, well, no, I'll start with the top. I'll get to that. What I propose now, also after talking to some people, is that even though, you know, I would love to move fast and design a thing and have something great, I think the proper thing to do is to make a document that really defines the problem statement in these different areas, that lists requirements of how we might move forward. And that can also be used to discuss what the priorities are that people, you know, feel. Do we have consensus on that something is an issue? Maybe we don't have consensus on certain things, and you know, it's hard to work on that. That's probably a good starting point. Having said that, the identity key role is a operational issue that I'm facing. So I need to do something a little bit more proactive there. Now, if we can have a discussion and it goes fast, then perhaps we can have something there that is really within standard. But if not, and I still need to do this, then what I would propose is that I make an informational document that describes how this works, potentially get external auditing on it as well. Preferably, I would get review from the working group though, and it would feed back into a IETF standard, hopefully. Plus, I will also commit to that if we do have that, I'm more than willing to change things that I had done as a temporary measure to follow the standard to be. Now, the final thing I wanted to say is some of you might have seen the document that I submitted with just myself as author, having, you know, where I documented some ideas also resulting from discussion with other people. That is not that document. That is just a document that I wrote because I wanted to have something tangible, so I could have discussions about, you know, what are possible mechanisms we might want to think about there, and it has helped and served that purpose. But to be clear, that is not the document that I'm proposing to write in the first bullet point. And that's it, really. So I guess my question to the group would be, do you agree that going for a problem statement and requirements documents in this space is a valuable exercise, and would you be willing to contribute to it? And that's it. No questions?
Super, thanks, Tim.
Okay.
And we can take this on mailing list as well.
Okay.
Yeah, thank you.
Thank you. Hey, everybody. I'm Igor Lubashev, and last IETF in Philly, we presented a new proposal for a source address validation algorithm that's using BGP as well as RPKI data. We received quite a bit of good feedback at the mic and after, and so today I want to talk about what's happening next with this work. Can you do next slide? Actually, next 2 slides. Next. So I'll start with a just quick recap of Barsev algorithm. Not going to go into much details. Look at the Philly presentation for more. Next. All right, so we have a pretty nice long pedigree of last 22 years since 2000 when BCP 38 was published, which says thou shalt do source address validation. 3704 invented feasible path RPF method. 8704 did an enhanced feasible path. And well, here we are today with Barsev. So the main advantage, the main innovation of Barsev is augmenting BGP-based methods with RPKI data. Just like 8704, it starts with let's find the customer cone for the interface in question, for the customer or peer interface. And it's also using ASPS data from BGP in a more advanced way, but fundamentally ASPS from BGP, but also looking at ASPA data as available. Once customer cone's been built, it's gonna find all the prefixes that belong to ASs in the customer cone using prefixes from BGP announcements and also looking at raw data. So what's the advantage? The biggest advantage is that the data available to Barsev is more than just the data that was previously available to algorithms that only use BGP. And that means that for networks that use some sort of traffic engineering and their prefixes or AS numbers don't show up in BGP, we have a way to augment that data and build a better self-filter list looking at RPKI. In some future, if customer cone has a perfect adoption, for example, of ASPA and RAW, Barsev can then build a perfect filter just from RPKI data. But it doesn't have to be. We don't have to wait for that future because it's perfectly happy to augment RPKI data from BGP. Next. Next slide. Thank you. So again, quickly going through Barsev operations. Step 1, build customer cone. Start with just a single AS number that's on the other side of your interface, peer interface or customer interface. Look up that AS number in ASPA, a customer auth relationship, or look up that AS number in all the AS paths that the router has received and looking for what is the previous AS number in the AS path. Should be stated that we're looking at every single BGP update message that's available, not just from this interface. So anything that received from any of the customers, peers, even your provider, if you get a full table from them. All right, so you discover some AS numbers, iteratively repeat the process. When you can't discover anything new, you're done. You have your customer cone, And then for the customer cone AS numbers, you look them up in raw, find the prefixes, you look them up in BGP update messages for BGP update messages where the originating AS is in your customer cone, you find the prefixes. At this point, it's kind of implied, but a good idea to state explicitly that the inputs, the BGP data that you are looking at should be pre-validated. So using RPTI, ROV, or any other validation method. So don't use invalid BGP data for SAV. All right, so you combine the two set of prefixes found from RAW and from BGP, and that's your SAV list. Next. As you can see, you don't need a widespread deployment of RAW and SPA for this to be useful. BARSEV can happily take data from BGP. The only place where RPKI data is useful is for networks that do some sort of fancy traffic engineering, so their prefixes and AS numbers do not show up in BGP feed. Most likely those networks that do this kind of stuff are more sophisticated networks, and that's most likely translates to them being more likely to actually publish information into RPKI. Next. All right, so what's new? Next. Most of the feedback we received revolved around things that we published in added a new chapter, like section 6 for operations and management considerations. Next. So first of all, it's very true that we're using RAW and ASPA information that was not really designed for it. And honestly, BGP was also not designed for SAV. But we looked at it and it seems to us that it's sufficient for the purpose. But there was a suggestion that what if we actually try to introduce sub-specific objects, RAW-like, and like they're very much like RAW and SPA, but they're designed for SAV. And there is clearly merit to the idea of let's use information specifically designed for the purpose, but there is also clearly cost to that. So one is you double the number of objects, and two, it's always a pain to keep the two synchronized for probably 99.9% of the cases. So we tried hard to figure out, find examples where asking the operators to publish RPKI data that's specifically for SAV and that they wouldn't publish otherwise, like when would it be harmful? And we couldn't come up with good examples. We've asked the mailing list. We still haven't received any good examples, so we welcome further discussion, further ideas. Next. The other feedback we received was around we need to give much more implementation guidelines to the implementers. This stuff, RPKI is not guaranteed to be 100% available or even consistent. So must fail open. It's a case for the traditional RPKI ROV case. Something fails, BGP should still work. And for SAV case, something fails, data forwarding should still work. So some of our suggestions. So number one is if a repository is unavailable when you're trying to refresh your cache, then assume that all previously valid signed objects is still valid. And so effectively extend the expiration. The idea is that most likely the objects are still valid. And number two is if you have successfully refreshed your cache, but now some previously valid objects have disappeared, probably it's a good idea to actually still use them from the local cache until they expire, unless they're on the CRL. The idea is maybe there is some sort of temporary inconsistency in the repository, in the file system, or some sort of synchronization problem. And honestly, if an object is not expired, it should be put on the CRL if you really don't want to have it. But more ideas, definitely welcome. Next. Just a quick plug for ASPA adoption. It really works well. It's good for its purpose of detecting BGP route leaks, but it's also very good for SEV, and there are updated drafts. Next. And so we're asking for more discussion, more feedback. So with the new version of the draft has addressed a bunch of feedback we received. Let us know. Is it good? Do we need to talk more with you? And since we did get some engagement from the community, we would like the working group adoption. Thank you.
Jared, do you want to go first?
Yeah, sorry, I screwed up. I haven't done
That's okay.
Didn't do the media echo thing. So on slide 9 and 10, I think it was slides 9 and 10 real quick, I have some feedback. So Igor, sorry to do this here. I need to describe to you some internal use cases we have at Akamai where this is not going to work. Just on the networking side and stuff, and then on.
So I'm happy to talk to you offline about that, but or if there is something you can talk publicly about, I'm happy to hear it too.
Yeah, so I mean, so we have internal interconnect customers that might get incidental transit from us out to the public internet if we have one of our clusters that becomes disconnected from our global backbone based on how the aggregate IP space is announced. And so it's possible that in those cases, we might direct a customer to a location that is off net, either because we've taken it offline for maintenance or some sort of other activity. And so the source address may be our customer's IP address that we're not really intending to provide transit to, but we also don't want to break. Because if there's an external system directing them to talk to a specific server, hypothetically speaking, that system may not know what is real-time connected to the backbone or not in the routing information. So that's something here that would make it challenging for us to go to our external network providers and ask them to implement this on our ports.
We can talk offline and get to get better idea about it. But so if we're purely talking about publishing, reluctance to publish ASPA data, raw data for SEV purposes.
Well, it may be that we have a customer that is a dark origin or something like that, where they don't want us to announce their IP space, right? So there's that. And then but we can talk offline about that. And then on 10, the next slide, the concept of using, stuff that's still valid, but kind of ignore the expiration. There's precedence for that in the DNS and the use stale.
Definitely.
That. And so I think that makes sense. So I just wanted to add that in.
Thank you.
Hi, Antoine Schure. I have a question. When we are implementing currently customer cones on the basis of BGP 84, there is a warning there for customers that have a quite large customer cone, a number of prefixes reaching more than 5,000. And I mean, our own customer cone is like 1.3 million prefixes. How is BARSEV going to change calculating prefix filters for that?
So I'm assuming that you have a lot of customers and your customer cone, like you said, is very, very large. I mean, clearly all the SEV techniques, they work best closer to the edge. So I'm not sure how well like a tier 1 network would be able to do anything like that. You need to, I mean, at that time, like at that point, you might even need to think about the size of memory on your
exactly.
router.
So I was wondering, is there a change in this approach, comparing it to, for example, calculating it from RIR data?
Well, it almost doesn't matter where you calculate it from. If you really have a very, very large CIDR list, then you have a very, very large CIDR list to consider.
Exactly. Yeah.
Right. So, and
so there's no inline processing or something like that.
the expectation, it doesn't really have to be computed on the router. It could be computed on a server next to the router using the feeds and just feed VRF to the router through some other means, through BGP, I don't care.
So in other words, if we can't do BGP 84 right now for some customer codes, we can't do it with BARSEV as well. That's the conclusion.
So it's not, if the question is basically a huge CIDR list and you don't know how to implement it, this doesn't tell you immediately how to implement it. Maybe there are ideas, but this is trying to come up with a more accurate SEV list if you could install it.
Okay, thank you.
Hi, Nan, please go ahead.
Oh, sorry.
Hello, Nangang from Huawei Technology. Just want to share an observation. What I want to say is that what happened during the evolution of source address validation mechanisms. What I found is that we are considering more and more information to generate accurate SAV rules in particular scenarios. At the beginning, we can manually configure ACL rules to filter particular source prefix. We need to update these rules in time when the prefix change. And then we have strict URPF. We can generate these rules by considering local fib, and these local rules can be generated automatically, but under asymmetric routing is not accurate enough. So we have enhanced URPF, and in enhanced URPF, we consider local RIB information. So we are considering more and more information into consideration when we generate SOA rules, and now we are considering more extra information besides local RIB to generate more accurate rules. And okay, a conclusion. In other words, if we want to generate accurate SOA rules, we need to import extra information, and of course, extra cost will be imported. So there is a trade-off between the potential benefits and the extra cost. Thanks.
Certainly, yes. We are trying to get more information than available in BGP, and there is a computational cost. There is a cost of maintaining RPKI caches, but the idea is that people are going to be doing it anyway to process RPKI for BGP purposes. So yes, this cost is amortized.
Job Snyder's Fastly. Section 651 suggests that you should refresh daily, but there's existing work that recommends refreshing at least once an hour, preferably once every 10 minutes. And I don't see a justification to deviate from what is already the established best practice in that regard.
Thank you. Yeah, that's very good feedback. I mean, when daily was just taken without just an initial placeholder. Happy to change.
And then the militant side of me trips over ignoring expiration dates. I would not implement that in my validator. I see no justification for doing so. The document already describes a sort of fill open mode where it's suggested to fall back to enhanced URPF or enhanced feasible URPF because that downgrade is better than suspending SEF entirely. And I think it is very good to consider a path towards a fill open of sorts, but ignoring objects either being delisted from a manifest, which would cause them to not appear on a CRL, but it does mean that the CA revoked the ROA, or the expiration dates is unhelpful, I think. So I would warn against changing the RPKI validation algorithms as we understand them today.
Thank you. So the recommendations were not for processing um, the traditional RPKI ROV, but only for SAV purposes. The concern is that if you start ignoring, pretending objects don't exist, for example, you fail to refresh your cache and the object is expired in the meanwhile, that falling back to enhanced RPF, that means that some of the data that was available from RPKI will no longer be available and your sublist will become smaller. And that's what you don't want. So you want to err on the side of your sublist being bigger than it has to be than accidentally smaller than it has to be, because smaller than it has to be is failing closed.
But what is the garbage collection mechanism? Because I do understand your concern that it is operationally potentially a little bit nicer to be more permissive than strictly needed.
Mhm.
But somewhere in the decision path, there is going to be an event horizon where you go left or right.
Right.
So
Correct.
for instance, if I see a traffic stream coming from you towards me and I own the IP space and I want to block it and I remove the ROA authorizing you to send traffic for that source, and others continue to use that ROA that now has been removed from the system, pretending it didn't expire or pretending it wasn't removed.
Put it in a CRL.
But then you are changing some fundamental parts of how RPKI was designed to work. The CRLs are shrunken, both based on what has now properly expired, but also if it's not listed on the manifest, you don't need to add it to the CRL. So CRLs in the RPKI are fairly small, like it's an average of say 7 to 10 entries per CRL. And this is possible because manifests are strictly interpreted. So now you're changing a few complications of the RPKI in a way that I think is
I think it's a great discussion. I mean, we can definitely see what the guarantees of consistency that you could expect from the repo versus so if we can believe that repo has a good consistency, that we will not accidentally drop objects, then we don't need this recommendation.
Manifests were meant to provide very strong guarantees about the integrity of the repository.
Okay.
But then you still have your concern about, hey, maybe I want to operate things on different timers. And to overcome that concern, you might want to consider defining a new signed object where the expiration date is what you want it to be. If for some reason the expiration date of ROAS is unsuitable for this protocol's purpose, a new object could be defined that has slightly different rules. But if anything, it would be good to put in the internet draft just the concern of garbage collection being stricter than is applicable to this particular case, but then also find other ways to shrink the SAF filters as time progresses.
Well, thank you. That's perfect feedback. That's awesome. So we'll definitely work with you and come up with something improved.
Thank you for your time.
Thank you.
Ties de Kok, RIPE NCC. Sorry?
You want to wait? There is a queue. Sorry about that. Ming, you have a question? Come on.
Yeah, it's me. Okay. A very good presentation. I think it's very good improvement for EFT. But I have a question. In page 10, you said that we use RPKI as the tools to find hidden prefix, right? So in this case, if RPKI is failure, I think that will make this prefix will not be included in SAP table. So in this case, it seems like the legal traffic would be, be blocked. Is this kind of a risk, right? I mean, correct?
So it was a little garbled, but I think I understood the question as, right, if we're augmenting a table from RPKI data, then RPKI failure will put that prefix at risk. And that's why we have this implementation guidelines. So some of it looks like it's pretty clear, and the other one we need to have more discussion on, but that basically points to the need to make sure we're very careful at managing our cache so that any failure doesn't result in failing close for any prefix. If I understood the question right.
Thank you.
Doug, you are next.
I just wanted to make the point that, as far as RPKI object staleness, I think we have to follow what the basic RPKI validation algorithm is doing and what route origin validation is doing. If for no other reason that, subtle issues of RPKI object staleness is something that's typically in the purview of the validator. And this algorithm operates on BGP rib-in data, and those two data sets are typically on different platforms. So it sort of aligns with Yob's comment that if we're going to change the semantics of behavior around staleness, we almost need a new object, which I think we agreed to stay away from. So we can have the discussion about the treatment of staleness in RPKI validation, but we should be consistent with whatever is going on in ROV.
Yep. So definitely, just like I said to Yoba, that's good feedback, and we'll definitely come up with something that makes sense.
Please, you still have the okay. Thank you. Thank you, Igor.
Very good. Thank you very much. And so the adoption that we're going to make a call on the list.
Sure, we'll take it. And I encourage you to take the discussion also on the mailing list.
Definitely. Thank you.
Tom, you're next.
Okay, thanks. Next slide. Okay, so to recap briefly on this document defines a new type of signed object called a trust anchor key object, or TAK object. And that can be used by trust anchors to communicate TA certificate URL changes and TA key changes to relying parties. So the aim here is to simplify the key rollover process, get support of some sort into relying parties, and that in turn will help with HSM vendor lock-in. Next slide, please. So this was presented at the last meeting as at version 10. There were three main changes between version 10 and 11. The first was to note that some relying parties that can't support automatic transition can still get most of the benefit of the model here by doing a sort of semi-automatic type thing. So for example, RPKI client is a relying party that can't do automatic transition because by design, it's not permitted to update the key material that's being used. But it can still fetch the TAK object, validate it, alert the user to a new key, track the acceptance timer period, and then when that expires, it can request that the user update the key material manually. The second change was to note that TAK object distributed out of band is not somehow more secure or more reliable on account of it being signed. It's pretty much just a TAL file in a different format. The reason it doesn't matter that it's signed is because if the relying party trusted the signing trust anchor, it'll be getting it in band. So, yeah. And the third change was to add some text to the security considerations around what we're calling, for lack of a better term, temporary TA compromise. So this is where a trust anchor is using a device like an HSM that permits key signing without actually having access to the raw key. An attacker gets access, or rather control, of that device somehow, but then the trust anchor is able to regain control over that device. So a trust anchor in this situation might think, great, I've got control back, everything is fine. But at least in the presence of attack objects, there are some scenarios where that temporary access can cause long-term problems. So by documenting that, trust anchors can consider what to do if something like this happens and update their processes accordingly. Next slide, please. For 11 to 12, it's a bit simpler. The only change there was to add a comment field to the TA key structure so as to align it with the TAL file format from 8630. Next slide, please. There's been some implementation work since the last meeting. APNIX code has been updated for version 12 of the draft. Job did some TAC object validation work in RPKI client, which is now in OpenBSD proper. And Tim also did some TAC encoding work in a branch in Krill. And Job's and Tim's work was very helpful in finding problems in the APNIC implementation work. Next slide, please. Some things to discuss. Russ Housley had a suggestion on the list about adding some clarifying text to the signed object registry at IANA. That's, or rather on the author side, we think that's a good idea in principle. But because it's not strictly related to what's happening in this document, we think it might be better off as a separate thing. Job had a suggestion about removing the TA compromise section, which was added in version 11, because it's kind of hard to talk about this clearly. It might just confuse people, and it's not strictly necessary to the document as a whole. On the author side, we're fine with that, but Tees did indicate on the list that he thinks it would be worth keeping that text. And then the third suggestion was also from Job, adding text about certified destruction of key pair material. Again, on the author side, we're fine with that. Tees did indicate that the term certified invites questions about what certifications and so on, and it might be better off to avoid that if we can. Next slide, please. Apart from resolving those issues, there are some other suggestions from Job that are uncontentious, so we need to update the document for that. It needs some editorial work, particularly on the server side of things. The process for server-side implementations to follow is a little bit strewn around the document, so that needs to be consolidated. And there needs to be some text around the purpose of the acceptance timer, just to make it clear what that's about. And more implementation work would be good too, so particularly on the server side. And that's it. Thank you.
Yep. There is a comment or question probably from Russ. Russ, go ahead, please.
So you're absolutely right about my suggestion being like really small. But what I did is I looked for the next document that's updating that registry, because the previous one was already in Auth48, and Warren said, I won't add it that late in the process. So this seems to be the next one. And it seems really, really small thing to do a whole RFC for.
Okay. Yeah, thanks. Okay, thank you.
Warren?
Yeah, thanks. Russ said part of what I was going to say of, we couldn't put it in another document that was an Auth48 because that burnt me badly once before. So the next document that goes through, if it could include that, would be great. Could we go back a slide? What I was wondering is if the compromise text could maybe just be stuck in an appendix as sort of like, then it doesn't need to be as clear, and it's just a sort of like, here's some additional information that we can stay remove the TA compromise section. Maybe that could just be an appendix instead, if that works for, nope, doesn't work, okay.
Ties de Kok, right by NCC. I'll just clarify my main concern about key destruction here. The limitations that I've seen with the various vendors that we have looked at for HSMs is mostly that you cannot be certain that there's no copy of a key somewhere else. So we can have a certified process that shows that if that really is the only box, we have deleted the copy that's in that exact box which you include in the process. But you cannot really have guarantees about the thing being really gone, and it gets really muddy if you want that. So that's why I was opposed to that.
Okay, thanks. Makes sense.
Thank you, Tom.
Thank you.
Sriram, you're next.
Yes. So good morning, good afternoon, everyone. This is Sriram from NIST. I'm going to talk about the updated ASPA path verification draft today. Next slide, please. So we'll quickly look at changes in version 11 that was published a few weeks ago and compare it to version 09. We skipped version 10 because it was submitted and then we had a few more changes to make. So we submitted version 11 soon after. We received some good comments on version 11 already on the working group list in the last couple of weeks. We'll take a look at those comments and then the next steps. Next slide, please. So just to recap, we are doing ASPA-based path verification because it has the benefits of detecting and mitigating BGP route leaks, and also does the same for forged origin hijacks. So essentially, it's a basic form of path verification, does not do a complete path verification, but establishes that, that it is a feasible path and it is free of any route leaks and also catches forged origin route hijacks. Next slide, please. So the changes in version 11 compared to version 9, the algorithm needed some corrections, and we realized that I made a presentation about a year and a half back at IETF115, that is the Sriram 1 reference. And that pointed to some enhancements that were necessary in order to get rid of some mix-up between the invalid outcome and the unknown outcome. And we took care of that in version 09, but additional refinements were also necessary, and they are now in version 11. These additional refinements are in the form of AS set handling, route server AS, how to treat that, some other refinements related to clarification about applicable AFI-SAFI, and a statement about AS configuration. And we, in addition to these refinements, we devoted a good amount of effort to get like pretty good text clarity throughout the document, but there still needs to be done a little more. Next slide, please. So on the AS set handling, we had a pretty good discussion and feedback on the working group a few months back. The pointer to that discussion is provided at the bottom of this slide. So now, based on the working group discussion and general consensus, the presence of AS set anywhere in the BGP path would make the path invalid per ASPA verification algorithm. So that's in the draft in version 11. Next slide, please. So for the route server AS also, we had a good discussion on the thread, on the working group list, and the thread is provided at the link to the thread is provided at the bottom of this slide as well. We had basically, based on that discussion, it emerged that we had two choices. Choice A is to add the RSASN to the AS path in the case of a transparent AS. And in this case, we can apply the algorithm for downstream paths. If we go with choice B, we would remove the RSASN from the AS path in the case of non-transparent RS and apply the algorithm for upstream paths. So in version 11, we included choice B. They are equivalent. They give you the same results for the path validation under any scenario. So they are equivalent. We chose choice B. In addition to that, we should also mention that now the draft makes it clear that an RS client must include RSAS in its ASPA, and also an RSAS must register an AS0 ASPA. That would facilitate the path verification unambiguously, and it will make it work right. Next slide, please. So we just have a clarification about the AFI-SAFI. Keyur had some feedback on this, and we have since included this statement. So basically, it says that the procedures described in the document are applicable only for AFI1, AFI2, meaning IPv4 and IPv6, and in both cases with the SAFI1 or unicast. And the procedures must not be applied to other address families by default. Next slide, please. We also have a statement about AS confederation, which is new, and that simply says that the ASS on the boundary of an AS confederation must register ASPAs using the confederation's global ASN or global ID, and the procedures for ASPA-based path validation in this document are not recommended for use on eBGP links internal to the confederation. So I think that's clear enough. Next slide, please. So, like I said, since we published version 11 a few weeks back, we have received comments from a couple of people, and that includes Claudio and also Rich Compton from Charter. Good set of comments, both of them, and I have responded to them on the list, and those are comments that we can incorporate into the next version, version 11. In particular, Claudio read the draft very carefully, and he offered a very good extensive set of comments. His main difficulty with the draft, or main suggestion is to improve the readability. So he found that the draft by itself, especially in the algorithm description, it gets a little intricate. And at that point, he made use of Sriram 1, my IETF110 presentation. So that has a nice set of figures explaining the algorithm. It has good notation to begin with, and based on that, it builds on the description of the algorithm. So he found it essential to make use of that in order to be able to understand specifically the algorithm description in the draft. And that's where he said it can be improved a whole lot. So what I'm proposing as part of the next steps is that we can follow the notation and style in Sriram 1 reference to better describe the algorithm. That's quite doable. And it will make the description shorter and more concise, and also clearer. And we will publish a version 12, sorry, in the next few weeks. And at that point, we will invite some more feedback from the working group, and hopefully then it will be in good shape. So at that point, Job has suggested that we should wait a few months and solicit implementation experience reports, and then we can proceed to working group last call, right? So, and then I have a couple of slides, backup slides. If we can just quickly move to the next one after that. So in case you are interested and want to understand how the RSAS is treated and how these two alternatives, the choice A and the choice B that I mentioned earlier, if you would just want to get some clarity on that, I won't go through this slide, but you may look at this slide to figure that out. And please ask me questions if you have any on the list or one-on-one. So thank you. We can move on to the questions.
Job. Job Snijders, OpenBSD. It is our intention to implement ASPA verification in the next 3 to 6 months, which is fairly soon. So that's where my desire and recommendation stems from, to wait a little bit with working group last call until we finish that implementation. And I hope some other vendors will also start working on this in the next few months.
Thank you, Job. I should add that at NIST, we already have implemented this pretty much close to this latest version of 11 ASPA path verification. And we also have a number of test cases that we run against to verify the implementation. So we have that all available on GitHub, and we welcome anyone interested to pick that up and make use of the tests or make use of our implementation for if you're running some experiments. We're welcome to do that. In addition to that, I must also mention that that Claudio Jiker, he also mentioned in his comments on this version 11 on SIDROPS list that he is implementing it. So it would be nice to, I mean, we know that that there is another effort as well, and Job mentioned another one as well. So it's good to see that there are multiple implementation efforts already on way, available or on way. Thank you.
Yeah, Tim Ruijsels, Ananda Labs. So on the CA side, we've done an implementation based on the syntax that was in one of the documents, but I think we need clarity on whether that's going to be the actual syntax. Basically, that's what's stopping us from doing it on the validation side, because, you know, experience of implementing something that wasn't solid and then having to revert it wasn't very nice. So if we can have clarity on that, I think we can do more work on the validation side as well.
I think Job can respond.
Job Snijders. I think in terms of the profile, in my perspective, is now stable. There's multiple implementations. Specifically, your CA implementation helped me develop my validator implementation. The current profile draft contains, I think, references to 7 or 8 implementations that to some degree have tested interoperability with each other. So as far as I'm concerned, unless there is a grave mistake in the profile that needs addressing, we should stop touching the profile. And the contention between the current version of the profile and the one before that is of a somewhat cosmetic nature, and that to me does not count as an urgent pressing reason to change. And then from a CA side, I am ready to publish ASPA profiles conforming to the latest profile in the public RPKI, and we'll do so in the next few months.
Tistekok, RIPE NCC, if we're talking profile anyway, we now have an implementation of the current draft ASPA profile in the CA environment available on our testbed, and we will publish documentation on how to create objects soon. It appears to be interoperable, not causing problem with validators. However, one implementation will complain about unknown objects.
Super. And my comment would be that the contentions that we are seeing on the profile side, maybe that's something we should take to the mailing list and discuss. Also, a comment to my fellow IDR chairs. This is something IDR should be looking at least, and reviewing it. So Chris and I will follow up with you folks. Thank you, Shriram.
Thank you.
Job.
Hello, everyone. Loud and clear? Yep. I wanted to present an update on a recent effort to do a BIS version of the document that specifies the route origin authorizations profile, RC6482 BIS. Next slide, please. The BIS effort started because I noticed an oversight in the original specification with regards to the mandatory presence or absence of AS identifier extensions. And I thought to myself, well, I'll just file an errata. Next slide. Unfortunately, it was shut down. To me, this seems a little bit of an arbitrary decision by the powers that be. I feel that what's currently deployed in the wild in terms of objects in the repositories and how validators react to them, and other erratas that have been approved similar to this one, it should have been verified, but it didn't. So next slide, please. Buckle up. Here we are, ABIS document. Next slide. The BIS document is available for your consideration. I started with a verbatim copy of the original RFC to really try and make the changes from revision to revision as minimal as possible so that the whole crowd can follow the story and see that even though some of the changes might seem intrusive, that all in all, these are very nuanced changes to tie up any and all loose ends the original RFC presented. Next slide, please. The goals of the BIS document, as far as I'm concerned, are to clarify that AS identifiers should not be present. I want to strengthen the ASN1 notation, pull in the verified errata that appeared so far, extend the document a little bit by providing an example that people that are implementing ROAS may find useful, and above all, maintain full compatibility with the ecosystem as we currently understand it. I'll go through these points one by one in the next slides. Next slide, please. So the ROAS payload contains essentially two elements. One is the origin AS, and the other element is a list of IP prefixes. And as we validate ROAS in an RPKI cache validator, all the IP prefixes in the payload must be contained in the 3779 extensions of the EE certificate and the parent certificate of that EE certificate, and that's parent's certificate, etc. On the other hand, the origin AS, or ASID as it's called in the profile, is an arbitrary value that can be set by the resource holder. So I can input anybody's ASN or even private ASNs, and it's really up to the IP resource holder to decide which ASN is the one that can originate the prefix. In other words, validators do not check whether the ASID in the payload is contained in the 3779 extensions in the certificate chain. And I've seen multiple implementers that made a mistake in this regard because from the original specification, the whole notion of AS identifiers is not described. And since in the payload there's an AS and potentially in the EE certificate, there could be something AS related, it is intuitive for people to assume that maybe they have some kind of connection. And by explicitly documenting that the AS identifiers extension must not be present, I think it becomes easier for developers to understand that the AS ID is not part of something that is verified to be contained in the chain of authorities. So that is what motivates this particular change. Next slide, please. About the feasibility of disallowing the AS identifiers extension in ROA EE certificates, there are currently 0 ROAs in the wild out of more than 130,000 ROAs, and none of them have this particular extension. I looked at various open source CA implementations, and none of them set the extension, the AS identifier extension on ROA EE certificates. And on the validator side, most validators will ignore the extension if it is present, and one validator will consider the ROA invalid if the extension is present. So I would argue that it is entirely feasible to add this additional constraint because it doesn't seem to stomp on anybody's feet. Next slide, please. All right, next topic, strengthening the ASN1 notation. The original ROA ASN1 notation was, I think, written in a time where there was less understanding of all the powers that and features that ASN1 can offer us and what the benefits are in being very concise with constraints. So for instance, the ASID is an ASN1 integer, and ASN1 integers can hold very, very large values, think larger than 64 bits, and also negative values. So I think it is super helpful to be very precise in this profile and explicitly disallow negative values or values larger than 2 to the power of 32. The slide you're looking at, what I've done is the red colorized text enclosed in square brackets is what is removed, and the green colored text in the curly brackets is what is added as its replacement. So let's go over these changes one by one. In in the container that has the optional version attribute, the ASID and the adder blocks, a change is made that IP adder blocks cannot appear an unlimited amount of times, but it can appear only once or twice. The reason for this constraint is that the address family is contained within IP adder blocks, and all ROA producers currently will at maximum insert 2 IP adder block structures, one for v4, which can contain multiple v4 prefixes, and if v6 also is v6 prefixes also appear in the ROA payload, another IP adder block is added. Inside this IP adder block, it specifies IPv6 and then a list of 1 or more IPv6 prefixes. So this feature of IP adder blocks being permitted an unlimited amount of instantiations is not used by any CA implementation. In retrospect, I think it shows that the data structure of ROAS should have done an inversion where, for instance, the API is on the outside of the container, but that type of change would prompt us to do a profile version bump, and that would then we would not meet our goal of compatibility. All right, so IP adder blocks is a quirky change, but it works out with everything that's deployed in the wild. Then ASID being constrained to 0 up to the power of 32, I think is fairly obvious. The next change is in address family inside the ROA IP address family structure, where the AVI is no longer permitted to be 2 or 3 octets, but can only be 2 octets. The reason is that the ROA specification, you need 3 octets to encode both AVI and SAFI, but you're not allowed to encode the SAFI. So according to the normative natural text in the original RFC, the only possible outcome is 2 octets. So it seems a bit silly to me to, on the wire, permit 3 octets and then error out because you specified the 3rd octet. So again, this is a change that is perfectly compatible with what's deployed out there. You're not allowed to specify SAFIs. So we clean up the room that would allow you to express SAFI. Onwards to max length inside the ROA IP address sequence. Max length, again, was an integer, unconstrained, so it could be negative, could be really large. But the reality of the situation is that max length cannot be smaller than 0, cannot be a negative number, that would not make sense. And it cannot be larger than the maximum prefix length of an IPv6 address, which is 128. There are additional constraints. For instance, in the case of an IPv4 ROA IP address block, the max length value can at maximum be 32. Unfortunately, it's super complicated to express this in ASN1. And while we do have a draft profile that introduces AVI context-dependent constraints, my personal take is that the ASN1 is utterly unreadable to both humans and most open source compilers. So I'm a bit hesitant to go down that path. Then the final constraint is in the IP address bit string. Again, an address is, if it's an IPv6 address, the address is going to be a maximum of 128 bits. If it's IPv4, it's going to be 32. It definitely is not unlimited and never larger than 128. And these constraints are expressed in the natural text in the original RFC to some degree, but I think it is helpful to also repeat these constraints in the ASN1 profile itself, so that the next person that takes the ASN1 profile and compiles it into source code gets some benefits of these constraints. Jeff, you jumped in the queue. Do you have a question specific to this or at the end? All right, next slide, please. All these changes are 100% compatible with all ROAs deployed out there. There are no ROAs that carry more than 2 IP addr blocks. There are no ROAs that have negative or larger than 2 to the 30 AS IDs. And max length and IP address also are within these constraints. So I think there's a good justification to accept these changes to the ASN1 profile because it does not break anything we're currently using on the wider internet. Next slide, please. In terms of incorporating verified errata, these were super easy. I just copy pasted a sentence that the inherit element in the 3779 IP address extension is not allowed. The ASN1 has been verified to compile and be complete in the latest version. Thanks, Russ, for your help on that. And since the document now in its native form is an XML to RFC version 3 document, the table of contents is automatically generated, and I get to tick off this errata without actually doing much. Next slide, please. I included an example in as an appendix in the draft. This is just the payload of a ROA, and I provided standard Unix utility invocations to demonstrate how the hex, the DR encoding transposes to output that is a little bit more human readable. And my hope is that if somebody writes a validator or a CA implementation, that an example like this would help them. Then again, there's, of course, in the repositories, there are hundreds of thousands of examples. So it's more there for completeness. Next slide, please. And with that, I would like to open up the microphone for comments, feedback. Also, please email to the mailing list, or if you want to have a private discussion, email the offers alias directly. Or if you like using GitHub, use that. Jeff.
Jeff has mostly nitpicky type stuff. So the main reason, historically at least, that constraints were not thrown out in a lot of ASN1 stuff is the tool set. Anybody that's tried to actually use any tools that do ASN1 parsing usually end up tearing their hair out, swearing at the authors, trying to actually dig through necromancy manuals to actually figure out what the APIs are supposed to be. So while I agree that additional constraints might be handy, then your real question is whether or not your implementation is going to slow down because you're increasing the difficulty to get the job done. Two minor points on some of the items you had in there. So like your AS numbers, you're trying to actually restrict them to be positive integers as big as an AS number can be. That's great. One of the weird side effects of leaving it just integer is what happens if you want to do strange things like we've effectively done with Slurm and other tools where we stick weird AS numbers in there like 0. If you have a negative number as a signal that allows you to potentially signal stuff later. Very similarly, like by not being proscriptive about the length of the addresses, you're allowing for something that's not v4 or v6 to eventually become specified. And my last comment's really directed towards the original spec. Encoding an AFI as an octet string was always stupid. It's an integer and it's bounded to two bytes.
If I respond to that, the constraints as used, can you go back to the ASM1 slide, please? One more. One more. Yep. The only two constraint types that are used here are a size limitation and a value range limitation, and those are supported by all the ASM1 compilers I'm aware of. So, yep, this is much later than, I mean, the original ROAS specification is, I think, a little bit more than 12 years old, so times have changed to some degree. Where we had more difficulty was instantiating new classes to the API context-dependent size limits. And there we found that compilers like ASM1C have trouble understanding what is happening. But I'm very confident that these constraints are supported by the vast majority of the ecosystem. Any other questions, comments?
Warren's next. All right. Russ.
So Russ Housley, there's when we were working on 3779, like Snack was the most common open source ASN1 compiler, and it only did the 1988 version of ASN1, and so all of that. So when you look at this, I think if you're using a tool that understands it, you will get a benefit. If you're not, you're going to have to put code around it to make these same checks anyway. So I see no harm in putting it here where you get a decode error or you'll get a checking of consistency error. But either way, you're going to have to perform these very same checks. And as Job said, I already compiled the module with the addition of a single semicolon that was inadvertently dropped. It works.
Could we go back to slide, I think, 3? So, yep, you're right. That was a judgment call on rejecting that.
An arbitrary judgment call.
I think allowing a comment is less of a big change than this. But I'm super glad that I rejected it because this looks like a much better outcome. So if I'd known this was going to be the outcome, I'd have hit reject faster. But yeah, I mean, it was a judgment call.
And I agree that taking this opportunity to do a BIS document is a better outcome. So I just wanted to, you were sitting right in front of me, be a little bit snarky about it.
Jared.
You have 10 questions?
No, I have just back to the slide 10. That had the ASN notation. So the one problem I'm kind of having with this is, I mean, I certainly agree that we're not going to have negative AS numbers, but in looking at this, I'm trying to think of the future as well. If we're talking about ASN1 compilers and code that, well, we may not like, dates back to the 80s, in some of these cases. I'm also trying to think about the future. So if we look at an equivalent time window in the future, could we have IP addresses or ASN values that exceed this range in the future? That by doing this, we are constraining ourselves from doing something creative when it may become operationally necessary. And that is one of my concerns in trying to make a change like this is, by going and doing these things, if for some reason we need to go and change all the ASNs or move them all to 64-bit or some other future number, even though today we may not imagine 32 to be, so far out of range. I have reason to believe that we would still be using the same BGP4 protocol, plus in that time frame. And so it's hard for me to believe that we would, since the universe of people using this is even smaller than the universe of people using BGP4 plus, that we would want to to implement a constraint to say, hey, this should only be 32-bit. Especially in this, because this is an outside encoding. This isn't a wire encoding.
This is wire encoding?
This is not a wire encoding for the purposes of this data storage, for actually signaling in the protocol in this place, because this is something that gets passed through that 1983 or later decoding engine for ASN.1. If we want to use something other than ASN.1, like the TLVs that we use in BGP protocol, like maybe we should be doing that. But if we're going to be relying upon ASN.1, which is what, for better or for worse, X509 relies upon, I'm concerned about constraining the numbers, even if today it seems rational because it's a valid range. But by going and doing that, we're going to foreclose that and make it much harder for people in the future.
Can I interrupt your beautiful monologue? If ASN numbers are specified to be, say, 64 bits or 128, the path to extend this profile is fairly straightforward. On line 2, you see a version. And if the semantics of the data structure elements would change, such as, hey, ASNs can be larger nowadays, you would use a new version number that has new upsize constraints.
Is this saying that we're going to increase the version number here to do your change?
No, these changes all reflect what is currently version 0 as deployed in the wild. So if we
is there a reason to constrain it now to perhaps unconstrain it later?
It's already constrained in all RP implementations. It's just not in the spec. And if we want larger AS numbers, which might happen, all we need to do is bump the version number and say ASNs can now be 2 to the power of 64.
Or we file a bug in the in those implementations to say, please accept the valid numerical range from the ASN1 encoding.
There's more plumbing if ASN numbers are extended, like RFC 3779 would need to be updated.
Sure. But the list of things, I'm just wondering, do we want to be adding to that list of things in the future that would, future debt when it's not necessary now? And I haven't heard a compelling reason to make that change other than, well, people implemented it this way now, maybe for this thing that isn't also you claim isn't being used either. So I'm also wondering why we're spending a lot of time mucking with it. Sure.
George Michelson, APNIC. I actually have 2 points. They are unrelated. I think there is significant benefit in being narrowly specific and arguably prescriptive in binary structures like these, because the primary risk here is bad actors, not good actors. And the negative number wraparound, the unexpected behavior, and the we didn't expect you to use it, but we didn't define it, concern me from risk. And I know that that's the hand waving, unknown risk statement, but I do see this as bad actor threat. We've got people with implementations and they don't have defined constraints in the ASN1. If it turned out writing a negative number caused an out of memory event and it was in routers, that would be very unpleasant. I'd rather we wrote specs which narrowed that opportunity. That's my personal belief. And if what you're doing has significant on-the-wire binary compatibility for good actors, it does have a certain zero cost quality. And that again is good. And I would absolutely wish to applaud and welcome the work Russ does using well understood validator to check behavior. I think it's a huge net benefit to the community. So thank you for doing that. So now I want to make another comment, and it is a personal comment. I wish you to understand that this is not a reflection of APNIC, and it actually is not directed at you. It's a comment to the chairs and to the AD. It's something I said to Warren informally over breakfast that I think should be said publicly.
Is this a marriage proposal?
The errata and BIS process in IETF in the wide is insufficiently understood and I feel documented. And irrespective of the merits of this BIS proposal, I believe risks of contention and dispute around how BISs happen actually is a problem that should be addressed. And it is a working group chair matter and an AD matter. It's not a matter about authors. It's about what should the IETF say is how these things are done. It is a personal comment and it does not relate to the specific work. Thank you.
Any more questions or comments for Joe? Yeah, no? Well, thank you, Joe.
Yeah, final sentence. To reiterate, my goal with this BIS document is to tie up any and all loose ends. So for instance, there's a part of the specification that talks about 2 out of 3 permutations with a certain data structure. I intend to add the third one for completeness. And at some point, my hope is that we have understood all loose ends and documented everything that must be absent or present, and then go for working group last call. So if you want to contribute to that effort, please help review the document as it is and send comments, concerns, or paragraphs to the authors. Thank you all.
Thank you. And that's a wrap. We will see you again in Yokohama. Till then, stay safe. Thank you.
This is the problem.
Have some faith, Jared.
I understand the desire to specify only what's valid today, but by specifying only what's valid today, it makes it more difficult to do the extensibility in the future.
There are extensibility paths, both in X509 and in Protos.
Well, yeah, I mean, having spent a lot of time doing extensibility stuff, that stuff is.
Oh yeah.
We can end the podcast and start it.
I will not make such claims.
But it is what it is. You can't do much.
It's a version of protocol. Like 64-bit ASNs, I know exactly this.
That is a lot of fun. For a team that's small, it's a lot of fun. Once they grow, yeah. As soon as this is done.
It's hardening the system in a negative way that prevents, or that makes it harder when it becomes necessary for the next generation, 5 generations from now, to extend this further. And that's what I'm really concerned with, is unnecessarily foreclosing on something which regardless will still need to be done on the implementation side as well. Because I can still, there's nothing stopping me from putting on this, putting in that ASM component. It has to be. Yeah, and this question of parts are going to do that, but you need to also check after, which you're going to need to make sure whether and if you're using like a type of like if you're using a